to touch base, we have done NFA DFA, and if you look at the My Times, this is actually your My Times module site. After tutorial 3, this tutorial 4, it says pumping lemma, okay? But pumping lemma is not there for test, but it is there for final exam, okay? So for covering the test topics, so what I'm going to do is I'm going to jump to tutorial 5 PDA, and after completing PDA we will come back to pumping lemma, okay? Because if you look at the lecture slides, or if you look at the lecture topic, it will say pumping lemma and PDA, you see? So I'm just covering PDA first before going to pumping lemma, that's all, okay? So we will do pumping lemma, we will not skip, but we will do it after completing PDA, okay? So I'm going to run through quickly the idea behind PDA, and then jump into the tutorials on solving problems using PDA, okay? Yeah. Okay, so what you see here is a stack, and see what happens is with your NFA DFA, we say there is limited memory, okay? With NFA DFA, there is limited memory, okay? Limited memory in the sense, in NFA DFA, it can store only the current state, it cannot store the previous state, okay? That's what we mean by limited memory in an NFA or a DFA, okay? So you may ask, what do you mean by current state and what do you mean by previous state, okay? So for example, if I take a language that is equal to A length n, B length n, where n is greater than or equal to 0, okay, then the example strings are going to be lambda, because n takes a minimum value 0. This becomes 0, this becomes 0. It means A is repeated 0 times, B is repeated 0 times, so it becomes an empty string. So lambda, if n is 1, A length 1, B length 1, that is A and B are going to be repeated 1 time each. So you will get AB. If n takes a value 2, you will get AA, BB, and so on. Okay? So, what this language means is the alphabets are A or B. There is no comma here. And A's are followed by B's. And the length of A and B are always equal. Okay? Length of A and B are always equal. So, if I take n is equal to 2, then I'm going to have the string A, B. Correct, right? So, an NFA or a DFA is not possible for this language. Okay? An NFA or a DFA is not possible for this language. Okay? Why it is not possible for this language means, if at all I want to construct an NFA for this language, the only possibility is I will have a machine, something like this. So I may say A here, B here. So this will be my, if at all I want to This will be the NFA. But this NFA can actually accept valid string as well as invalid string. So for example, if I give AABB, A one time, A two times, B one time, B two times, it accepts. Okay, it accepts valid string. This machine will also accept invalid string. For example, if I take a string ABB is not in this language. Why? Delta of A and B must always be equal. Okay? But here, A is one time, B is two times. So it is an invalid string. It's an invalid string. This machine will accept this invalid string. For example, A means A, one time B, two times B. Okay? So what I'm trying to show is, this language is called as not regular, meaning it cannot be implemented as an NFA. Okay? When it cannot be implemented as an NFA, it cannot be implemented as a DFA as well. Okay? So why this issue happens is, it has limited memory. Right? So limited memory means, if I want to satisfy this language, what I am doing here, I am producing two A's, I am producing equal number of B's. Okay? Whereas, I am literally counting A one time, A two times. Okay? So I have produced A two times. So same number of times I have to produce B. So I have to store this count to somewhere so that I can produce the same number of B's. Okay? So when I am here, for example, I'm writing this string again. A. When I write A, this is a correct state. Okay. When I write A again, this is a correct state and this becomes a previous state. Okay. So when I put A here, this is a correct state, this is the previous state. I'm only writing A here. This is the correct state. Because the machine just wrote this A. Okay. After producing 2A, it has to remember the count 2. So that you can produce equal number of these. So this has to be stored somewhere temporarily. Okay? In your machine, you use a stack. Stack is a sequence of the new location that is meant for temporary storage. Okay? So in our computer, this temporary value will be stored in the stack. Right? So that when you write a program, we can produce equally length of A's and B's. So here what happens is NFA DFA has this memory. You can no longer the current state. So when it writes B, this is the current state, and this is the previous state. Okay. Since the machine no longer the current state, this is lost. And this is lost, it cannot count how many B's to produce. Okay, it cannot count how many B's to produce. So to overcome this difficulty, what scientists did was they introduced stack into the NFA DFA as memory. Okay? The problem with NFA DFA is memory. It doesn't have enough memory to do counting or to remember the previous thing. So stack was used as the memory in NFA DFA. Okay? So if you add stack as the memory to NFA DFA, it becomes a PDA. So you may wonder why it is called as push down automator. So stack always follows LIFO principle. That is, last in, first out. It follows LIFO principle. So normally we use two operations, push and pop. Push means push something into a stack. So for example, if I say push A, so your stack pointer will be here. So this is the bottom of the stack, right? So push A means it will be here. Okay, so this is the stack top now. Okay, this is the stack top now. Okay, so stack pointer will be pointing here now. Stack pointer always points to the next vacant location in the stack. Okay, so this is the stack top. So now when you say push B, B will come here. So this will be, just remember, don't forget about the stack pointer. You just remember about stack top. So this will be a stack top. Okay. Now if you say push C, C will be here, and this will be your stack top. Okay, like a stack of books. Okay. So now if you say pop, so if I say I want to pop A, I cannot pop A because it follows LIFO principle. Last in, first out. Last came in was C. So only that one can come out first. Okay. I can pop C. So when I say pop C, the top of the stack will be popped. So now your stack top will be here. I cannot pop A. I can only pop something from the stack top. So what it means is, in a stack, you can push something or insert something on top of the stack. Okay. So now this stack top, right? So now you want to push something. It will be pushed on top of the stack. On top of the stack. So you can push something here. If you want to pop something, you have to pop something from the top of the stack. This is the stack top. Okay, you have to pop something from here. Okay. So I cannot pop this or this. We can always only pop the stack top. That is whatever is the stack top, or we can push something on top of the stack. Okay. So with this introduction, so I am going to jump into the okay. So this language, I said we cannot implement in terms of NFA DFA, right? But this can be implemented in terms of a stack. So I'm going to tell you the concept. So stack is here. So we take an example string, namely AABB, which is a valid string. Okay. So when we program this PDA, why it is called as PDA? PDA stands for push down automata. Why it is called as push down automata means when you push something into a stack, it goes to the bottom of the stack. Okay. Push down. The stack grows bottom up. Okay. And that's why the PDA is called as push down automata. Automata means machine. Okay. So we use stack as the memory in this machine PDA. So when you push something, it goes down into the stack. Okay. That's why it got the name push down automata. Okay. So now, we are going to program the machine. You are not seeing the machine. I'm not showing the machine yet. I'm just showing the memory here. What happens in the machine's memory, which is very important to us. So when I see A, I'm going to say read A, push A into a stack. Next, read A, push A into a stack. When it comes to B, I'm going to program the machine as read B, pop A from the stack. Read B, pop A from the stack. Entire string has been read or entire string has been processed. Stack is empty. Halt and accept. It's a valid string. Okay. What happens if you have a string like this? It's an invalid string, right? So what happens to this? Let us see. So A means the program remains the same. Instruction remains the same. A means push A into a stack. Again A, read A, push A into a stack. Read B, pop A from the stack. The entire string has been processed. Stack is not empty. Invalid string. So you have to remember, in a PDA, the stack must be empty before processing a string, and the stack must be empty after processing the string. And the machine must halt in the final state. Okay. So if I take a string like this, let me take a small string to save time. ABB is also invalid string. What happens? A means push A. Right? So B means read B, pop A. So again B means should be pop A, right? But the stack is already empty. So this letter of the string cannot be processed. Because B means our instruction is pop A, but the stack is already empty. Okay, we cannot pop an A out of an empty stack, right? So before the entire string could be processed, stack is empty, right? So it's also invalid string, halt and reject. Okay. So with this introduction, I am going to go into the example problem. I am going to explain. Then we will do one more problem. Then we shall discuss about your test and when we do the replacement class. All right. So what this question says is construct a PDA using state transition diagram. So the diagram you see is a state transition diagram. Okay. In NFA, DFA also the diagram you see is a state transition diagram. For the language set of strings that are element of A or B clinesta, where W is a palindrome. So I think palindrome you should have discussed earlier in your data structures or programming language, or you would have heard definitely somewhere. Palindrome is a string that when you read in the forward direction or in the reverse direction, it reads the same. Okay? Palindrome is a string. When you read either in the forward direction or in the reverse direction, it reads the same. Okay? So take the famous music troupe in the 70s, ABBA. Okay? You read in the forward direction, it is A, B, B, A. You read in the reverse direction, it is A, B, B, A. It's the same. A, B, B, A, A, B, B, A. So it reads the same whether you read in the forward direction or reverse direction. Okay? Is a palindrome. But here, it says the alphabets are A or B, clinesta. So A or B clinesta means the string by right up to here, what it means is the string can be any combination of A or B. Clinesta means any combination. Okay? So A can appear first, B can appear first. Up to here, up to that vertical bar. Okay? But after the vertical bar, which we read as where, it says where the string is a palindrome. Yes, your string is made up of A or B, made up of the alphabets A or B, no issue. But what is the pattern of string? The pattern of string is a palindrome. Not any combination of A or B are allowed, but the combination of A or B that is allowed is the string should be a palindrome. So what is a palindrome? Whether you read in the forward direction or reverse direction, it reads the same. Okay? So what can be the example strings? Example strings, I have put A, okay, A single letter, whether you read in the forward direction or reverse direction is the same. B is the same. Same thing with ABA, okay. Forward direction, reverse direction, reads the same. ABBA, forward direction, reverse direction, reads the same. Okay. So what you're seeing here is, you are seeing strings that are odd length. You are also seeing strings that are even length. So meaning, we can have an odd length palindrome. We can have also an even length palindrome. Okay, we can have an odd length palindrome or a string with even length also as a palindrome. Some of you may have a question. Here the question is A or B clinesta. So clinesta can take a value 0. When it takes a value 0, you can have an empty string. Is empty string a palindrome? Theoretically, empty string is also a palindrome. Okay, theoretically or mathematically or formally, empty string is also a palindrome. Unless I define a palindrome as, okay, a set of strings that are made up of alphabets that reads the same in the forward as well as reverse direction. Okay, made up of alphabets. So when I say made up of alphabets, right, I need to have strings made up of alphabets. An empty string has no alphabets. Okay, so if I do a definition like that, then I can say empty string is not a palindrome. So don't confuse. Just remember, make your life easy. Palindrome in general, it means when you read a string in the forward or reverse direction is the same. So empty string means there's nothing. When you read nothing in the forward or reverse, the same. It doesn't going to change. It doesn't going to change the theoretical definition. So empty string is also a palindrome. Okay, but I have not given empty string here as an example string. I have a purpose, right? I don't want you to be carried away by an empty string, because a lot of time I've explained in NFA, DFA. Empty string means nothing. So whether it is an NFA, DFA or a PDA is a machine. You give nothing to the machine, it's not going to process anything. Okay, when you give nothing to a machine, it's not going to process anything. Okay. All right. So a palindrome can be odd length or it can be even length. That's what we are seeing here with the examples. So let us construct the machine. So even though the machine is there, I am going to construct and show you so that you understand what happens. I'm showing the stack here. Happens in the memory. Because our computer has memory. Without memory, our computer will not work. Okay? So which you should have learned, I don't know, because it's about something about history. We call it as stored program concept. All our machines follow stored program concept. Stored program concept means your software application has both program and data. Okay? The program and data has to be stored in the memory, and the processor, your microprocessor, has to fetch the program instruction by instruction from the memory to the processor and execute it, process it. Okay? So the program, which is a set of instruction to do something, is stored in the memory. When we say memory, we always mean main memory. Okay? That's why we say our classical or classic computer, classic means or today's computer, it follows stored program concept. Okay? You need to have a memory where you store the program, from where the processor actually fetches the program instruction by instruction and executes it. Okay? So we need to have a memory. So here the memory is a stack. All right? So the string is made up of A or B, is going to be a palindrome, right? So I am constructing the machine. As usual, this is a start state. Okay? And I am defining a final state as well. Okay? I am defining a final state as well. And I can have simply A, I can have simply B, right? A alone, B alone, right? So what I do is, when I say A, I simply say lambda stroke lambda. Okay? So when I write like this, what it means is, so observe me carefully. This represents the input alphabet. Okay? This position represents the input alphabet, because there are many ways how a PDA is constructed. Okay? If you go to the internet, there are many notations. The notations I follow is the most simplest one. Okay? That's what I can say. There are many other, I'm not saying other notations are wrong. This is the most simplest to write or to draw or to represent and easy to understand. Okay? There are many ways of doing it or representing it. If you go to the internet, you can see. Okay? So, you can follow anything. Not necessarily you have to follow me. You can follow whatever is there on the internet, on YouTube. But better understand what they do and then do. Okay? Don't get misled and don't do it wrongly without understanding what is explained on the internet. I'm not saying what is there on the internet is wrong. Understand how it is being done and then do it. Because if you are wrong, you are going to lose marks. It's going to affect you. It's going to impact you. So better remember that. Huh? Yeah. So this position mentions the input alphabet. So here the input alphabet is A. What this position means is the current stack top. So this is the stack. Okay? So this is the stack top now, because this is completely empty, you know. So this is your stack top. So current stack top is empty. Okay? And this position is called as the new stack top. That is, after you push or pop, so what is the new stack top? Okay? So current stack top, new stack top. We can also call this position as stack replacement. So whatever is there on the stack top, you replace with this. Okay? So current stack top is lambda, and I am saying new stack top is also lambda. So what it means is, if the input alphabet is A, current stack top is lambda, new stack top is also lambda. So it means do nothing to the stack. Okay? So doing nothing, for the input alphabet A, the machine goes from here to here. Okay? That's all. A has been processed. Final state, halt and accept. Don't forget the theory. Before processing the string, stack must be empty, and after processing the string, the stack must be empty. And if the string is valid, the machine must halt at the final state. So if you give A as input, A is a palindrome, A is given here as input, the machine processes it, but it does nothing to the stack. Okay, because this one current stack top is empty, new stack top is empty. So no push nor pop. So nothing is done to the stack. It goes here. It transits from Q0 to Q1. String has been processed. Machine is at the final state. So halt and accept. Okay. Same goes with B. If the input is B, okay. So what we do, we are going to say B means lambda stroke lambda. That is, current stack top is empty. New stack top is also empty. So I am neither pushing nor popping. So if I don't push nor pop, I am doing nothing to the stack. Because with the stack, we can do only push or pop, only two instructions. Okay. So B, transit from Q0 to Q1, halt and accept. Okay. So what happens if I have ABA? Okay. So ABA, so observe carefully. My thought process is, A means I'm going to push A onto the stack. I'm going to push A onto the stack. Still, that is the stack top. Okay. For this B, I'm going to say ignore the stack. I'm going to say ignore the stack. And for this A, I'm going to say pop the A from the stack. Okay. The entire string has been read or processed. Stack is empty. Okay. So I should transfer this thought process here in terms of constructing the machine. So what I'm doing, I'm repeating one more time. So A means I'm going to say push A on top of the stack. B means ignore the stack. Again, A means pop the A out of the stack. So pushing A, popping A, what I am trying to do is, after pushing something, I am checking whether I am popping the same. Why you know? If I pop the same, then whether I read in the forward direction or I read in the reverse direction, it is going to be the same. Okay? So the same applies if you go to BAB also. So when it's BAB, B means I am going to say push B into the stack. A means ignore the stack. Again, B means pop the B from the stack. So what I pushed, I am popping. Right? So it should be a palindrome. Okay? What happens if I have purely 3 A's? Is also a palindrome, right? This is also a palindrome, right? This is also a palindrome, right? Only difference between this and this is, what is the difference? This is an even length palindrome. This is an odd length palindrome, that's all. Okay? So, if it is odd length, what we will do? Push A, ignore. Push A, ignore. Pop A, pop A. Okay? Yeah. That's the idea. Okay? So let's take ABA, right? ABA and then BAB, right? So A means what I said. Push A onto the stack. So how to push A onto the stack? Stack is initially empty. So I'm going to say it here. So A means currently the stack is empty. Push A into the stack. Current stack top, new stack top. Current stack top, new stack top. So A means current stack top is empty. New stack top is A. So meaning I have pushed A onto the stack. So B means what we do? We ignore. Ignore the stack. Okay. So what this A, what I'm going to do? I'm going to pop the A out of the stack. Okay. After popping this A, the machine should be at the final state. Right. So B means I should ignore. I already have the instruction here. B means ignore the stack. Transit from Q0 to Q1. So after ignoring B, the machine is here at Q1. At Q1, I have A. My thought process was A means pop this A out of the stack. So write it here. So A means current stack top was A and the new stack top is lambda. That is, you are replacing the A with lambda, popping A out of the stack. Okay. So now BAB. So B means push B onto the stack. Okay. So current stack top is empty. So B means I should push B onto the stack, right? So I will write the instruction here. B means current stack top is empty. Push B onto the stack. That is, replace the stack top that is empty with B now. All right. So A means ignore. We already have the instruction here. A means ignore the stack, transit from Q0 to Q1. So this B means I should pop this B. I write the instruction here. If the input is B, current stack top is B, new stack top is lambda, meaning you are replacing B with lambda. Replacing B with an empty string, meaning you are popping the B out of the stack. Right? Done. So what happens if I have ABBA? Observe carefully, very easy. A means push A onto the stack, is already here. So A means push A onto the stack. B means push B onto the stack. Okay. So now what will be my intention? B means I have to pop this B. A means I have to pop this A. I can do that only at Q1. Because B means I want to pop this B. I have instruction here. A means I want to pop this A. I have instruction here. But my machine is here. The machine current state is here. A means I pushed A. B means I pushed B. Machine is still at Q0. I need to transit. I need to go from Q0 to Q1 to implement these two instructions. And that's why you see there, we have an instruction called, if the input is nothing, do nothing. Ignore the stack. When the input is nothing, okay, ignore the stack. We call this as lambda transition. That is, doing nothing, okay, doing nothing, the machine goes from Q0 to Q1. Right? Yeah. So sometimes we also do, right? We just want to while away time doing nothing. Okay, always studying, preparing for test, preparing for assignment. Hey, I just want to do nothing, lah. Just rest. Or we say lepa. Go to mama's stall. Anne or tetare. Right? Bring the tetare, one big mug. Sit there for 2 hours. Anne tamba ice. Anne tamba air. You know, dilute one sip of tea, one sip of water. After tea comes a half mug. Tamba ice, put some more ice. Some will be horrible. Anne, cold already. Manasa. The fellow will stare at you. If he's not happy, he's going to put some hot water into the tea and give you back. Then you say, Anne, not good one, huh? Kau. Make it stronger. Put some more decoction. Now, I used to be in a college that was about 20 years back. So at the basement, ground floor, we used to have a mamak shop. The fellow will always complain. Why? He means students between classes, they have a long break, right? For example, 1 to 2 class, then 2 to 4 no class, and 4 to 5 class. So 2 to 4, they go to the mamak shop, buy 1 cup of tetare, sit, spend the 2 hours there. So we got us hogging. Hogging means occupy the space for a longer time than necessary. So it prevents other customers to come in, you know. They always see the restaurant full, they go away. They'll say, what, your students, if they eat, take some extra time is okay. Sit here just with 1 cup of tea for 2 hours. They're preventing other customers from coming. Okay, let us not go there. So what I'm trying to say is, this is called as lambda transition. Lambda transition means doing nothing. The machine moves from one state, transits from one state to another. Okay. So why we want to do this means we should not overdo this. This is also possible with NFA, DFA, but I did not teach you. Okay, because students they overuse this. This should be used only when you have no choice. Here, I want to move from here to here. I have no choice. So I'm using lambda transition. After pushing A and pushing B, I go here. So that B means I can implement this, pop B. A means I can implement this, pop A. Entire string has been processed, stack is empty, halt and accept. Okay. Same thing can be done for BA, AB. BAAB is also a palindrome. BAAB, BAAB. Right? So B means I have instruction here, push B. So A means I have instruction here, push A. Now my thought is to pop this A, then pop this B. So it will read the same, either in the forward direction or reverse direction. So, but my mission is here. B means push B. A means push A. I'm still here. So for this A, I need to go here so that I can process this instruction. So I use lambda transition to transit from Q0 to Q1. I'm here. So A means I use this instruction to pop A. So B means I use this instruction to pop B. Okay. So it will work for any odd length or even length palindrome. That's all. Okay. Very simple. You go to YouTube, lot of materials will say, take this as Z0. Okay. So this is your stack top, you know. Some will use this symbol, you know. So, I mean, not wrong. I mean, not necessary. I mean, very, very simple and straightforward. They are not wrong. I'm not saying they're wrong. This is very simple, straightforward. That's all. Very simple. To me, cannot be more simpler than this. This is not my thought. This is also from one of the materials that are available. One of the textbooks, very old textbook. Okay, yeah. Not my thought. I'm also following somebody else's thought. But I found of all the different thoughts, this thought is very simple, very easy to remember. Okay. All right, 6:47. Okay, I have to stop here. No choice. I thought I can do question number 1, 1A. Never mind. We will do it during the tutorials after you come back after the break. Okay. 2 things before I open the attendance, because I know you will have questions. Just give me a second. I am going to your My Times module site. You go all the way down here. Okay, your test. Test, it says Thursday, 20th June. If you look at the calendar, we are here, 6th. Next whole week is the independent learning week. So here it says test. We will finish PDA only here, because Tuesday and Wednesday you have tutorials. So Tuesday and Wednesday, that is 18th and 19th. 18th and 19th, we would have finished the tutorials on PDA. Definitely we can finish. Okay. Immediately 20th, we cannot do test because you need some time, to go home, discuss the, take home exercise problems, study, prepare and all that. You need some time to digest and prepare for the test. So we cannot do it on 20th. So what I'm doing is I'm going to push it to 27th. Okay, I will change it here. 1 week I push. Every semester it happens. Don't worry. Okay. So I'm going to push it 27th. I will change it here. I know not all the 181 students are here. I will send a message through My Times as well. So it goes to all the students in the class saying that the test will not be on 20th. It will be on 27th. Because here we will finish the tutorial on PDA. So you have more than a week. But now, next week, you can still prepare for your test. You can still study NFA, DFA. You can still study grammar. Because test topics are here. In case you forget, it's here. I also given the structure. Question 1 will be on language and grammar. Question 2 will be on NFA, DFA. Question 3 will be PDA. Question 1, A, B. A will be construct an NFA for a given language specification. 1B will be, okay, verify whether the grammar that you constructed is ambiguous or not. That will be 1B. Okay. 1C will be, 2A will be construct an NFA. 1A will be to write a grammar. 1A will be to write the grammar. 1B will be to verify whether your grammar is ambiguous or not using past trees or derivations, or either past tree or derivation. 2A will be to construct an NFA. 2B will be to construct a DFA. Question 3 will have only A alone. A is just to construct a PDA. Okay. In a PDA also we have NFA, non-deterministic, deterministic, but we don't go for non-deterministic PDA and deterministic PDA. Why means with the NFA, DFA, all NFA has a DFA and all DFA has an NFA. Okay. But with the PDA, mostly they will be non-deterministic. We cannot change or convert every non-deterministic PDA to a deterministic PDA. Okay. Certain non-deterministic PDAs can be converted to a deterministic PDA, not all. Why means PDAs are inherently, by nature, they are non-deterministic. So when we construct, we simply construct. We don't put our thought, I want to construct a non-deterministic PDA or a deterministic PDA. No. Okay. So question number 3 has only one section, that is 3A, which is to construct a PDA. So you can still prepare for question 1 and 2 now. For question 3, we already have discussed the example. Okay, don't forget there are at least a few students who already came back and showed me, sir, I did this question on PDA, is it correct or not? I haven't even taught them yet, but they go and read the material and they started working on it. I'm not saying they are the majority, they are minority, but there are already students who are very proactive. So you can still start studying for PDA, but you can complete your preparation, after the week after next week. Okay, that is one. Second thing is, so test will be in our class, Thursday class on 27th June. Okay. One last thing. Last Thursday, I have no choice. I have to postpone the class or cancel the class. I don't say cancel because cancel is cancel. I use the word postpone because it is going to be replaced, right? So I will replace it after you come back from the independent learning week. But the university said it has to be face-to-face because it's a replacement class for a regular class. They said extra class, consultancy class, you can do online. But regular class, they said you cannot do online. University policy, I can't do anything. Okay. So I have to replace it face-to-face. Okay. I know Wednesday, usually for our school, 2 to 4 is a free slot. We don't have classes just to accommodate meetings, trainings, workshops and all that. Okay. But I know some students, if you are taking free elective, you may take a module in business school, or you may go and learn Mandarin, or Spanish, or learn some module in, hospitality and management. Okay. So the 2 to 4 free slot doesn't apply for those modules because they are taking a module from another school. So you may have a class. Okay. So I'm just throwing, you'd say yes or no. Monday, anyone has class between 12 to 1? Mondays, 12 to 1, anyone has class? Okay, there are a few hands. Okay. 2 to 3? Monday, 2 to 3? Oh, okay. Wednesday, 12 to 1? Oh, there are hands. 1 to 2 Wednesday. Wednesday 2 to 3. Still there are hands. Okay. Thursday 12 to 1. Thursday 1 to 2. Okay. Friday 2 to 3. Friday 3 to 4. Oh, again 2 hands. Okay. I doubted this. So there is no choice. So I have to put it on a Saturday. Okay. Okay, so what I will do is I will put on a Saturday, 11 to 12. So that I know you all wake up late. Okay. You all wake up late. But the only way I can help you is I have to switch this. all, the venue, and which Saturday. The Saturday will be after you come back after the Independent Learning Week, not next week. Okay? And if you really cannot make it, I cannot do online and record it. Okay? Yeah. That's what I thought. I told you also. I'll do it online. Those who cannot make it is okay. I will be still recording it. But the university said you cannot do online. Okay? So I have no choice. So weekday means no. I mean, you are not free. All of you are not free on a weekday, right? So I will put it on a Saturday, 11 to 12, so that if you are a late bird, you wake up late, you can still come. Okay? Yeah. If you still cannot make it, don't worry. So while I open up the attendance camps, you have any questions, you can ask me. Okay? So next week is a break week. So don't waste your time. It's not a holiday for you. You just don't come to class, that's all. Okay? It's not holiday for you. So you can start working on your assignment 2. Assignment 2 is an essay, so you can start working on your assignment 2. Don't wait for me to tell. Yeah. So you can start working on assignment 2. Okay. You can mark your attendance.
The 1, 2, 3, 4 meaning the people in 1, 2, 3, 4, right? So according to by email. So you write one by one. If you have 5 people, then write 5.
I will. Luckily, you reminded me something. I will push the submission for the self and peer evaluation as well, because the peer evaluation covers tutorial 1, 2, 3, and then 5. So 5 we just started. There are assessment questions to be done as assignment 1. I mean, you don't submit assignment 1, but you still submit a self and peer evaluation. So the last one we haven't done yet. So you may not be able to do self and peer evaluation. So I will push the self and peer evaluation submission to the same week where we do the test. Okay, I will push it. Don't worry. Okay, so no need to submit next week. I will change it on my times. Okay? Yeah.
So for tutorial 2, question 2a, I keep trying to do this question, but...
Okay, you will get only one derivation. Yes. I think I have also mentioned that in your My Times. Tutorial 2, question number 2, the question asked to do 2 derivations. 2 leftmost derivation. It purposely asked, I purposely asked, because I want you to go and try and come back and tell me, sir, I am not able to show, more than one derivation. I have mentioned here. Tutorial 2, question 2 has only one derivation or pass tree for the given valid string. The question intentionally asked to produce 2 leftmost derivations. It is intentionally done for the students to try out and see whether there are more than one derivation or pass tree possible as a learning exercise. So tutorial 2, question number 2, even though the question asks you to do 2 leftmost derivation, you cannot do. You go and break your head also cannot. There is only one derivation possible. Okay? Yeah. Okay, yeah? All right. Yeah. Yes. Yeah, you are correct. You are correct. But whenever you push on top of the stack. You have pushed here, right? Okay, so this is a stack top, no dispute. But when you want to push, it's not pushed here. It's pushed on top of the stack. We pushed here. So it's empty, right? Yeah. Okay. So we can also read like this. A means it says lambda stroke B. A means lambda stroke A. Sorry. B means, right? Like this, right? So A means you push A. This is a stack top.